Hello everybody and welcome to your video notes on 7.2 at the meets level. More or less the meets level is, so the basic level is being able to solve problems where something just falls horizontally off of a cliff or out of a window or something like that. That's your basic level. Meets is going to be where something, if this is the ground, something's fired up at an angle and it goes like that. And then being able to solve for anything that goes along with that. So basic is horizontal starting velocity, and meets is v1 at an angle. All right, so if you come over here, go ahead and pause the video and write this down in your notebook. But we have a ball is kicked at an angle of 25 degrees and a speed of 30 meters per second. That's important to know. And then somebody reaches up and catches the ball 65 meters away. Then the question is, how long is the ball in the air? T equals question mark. And then how far up did the person have to reach to catch the ball? So what we're going to end up solving for in this one, and apologies for my cough and sneezes and whatever. I've got a little bit of a sickness, but I'll get through it, and so will you. Anyway, so this one we're going to solve for the displacement in the y direction, and you'll see why. Okay, so first thing we should do is draw a picture, just so that way we can kind of see what's going on. So ball goes up like this. The angle is 25 degrees, and v1, the total v1 is 30 meters per second. We know that this distance is 65 meters, and I'm going to redraw this because actually it's something like this. This person catches it some sort of distance above the ground. Okay, so whenever you're doing these problems, whenever you see something like this where you've got v1 and you've got an angle like that, 100% without a doubt, you should first thing split that into x and y components. Okay, so the way we're going to do that is like this. So we've got our 30 meters per second here, got the x direction, and we've got the y direction. Okay, angle is 25 degrees. X component, since this is adjacent, we're going to use cosine, and you're always going to use cosine for the x direction. So the cosine of, not cosine of theta, but the cosine of 25 degrees equals, so remember that's the ca part, the adjacent over the hypotenuse, so that'd be the x over 30 meters per second. So then we'd end up with 30 times the cosine 25 degrees, and what we end up for that is 27.2 meters per second for the x direction. And then for the y direction, we're going to do the same thing but with sine, because of this we've got opposite and hypotenuse. This is opposite, this is hypotenuse, so you end up with 30 times the not the cosine, but the sine of 25 degrees, and we end up with 12.7 meters per second. Okay, so that's step 0, getting that out of the way. Then, just like what we had to do before, we're going to make a list of variables in the x direction and in the y direction. I'm going to switch colors for this. So we have our list. We've got the x components and the y components, and we're going to use this equation, d equals v1 times t plus 1/2 a t squared. Okay, so we're going to have dx equals, we're going to have v1 in the x direction equals, and their acceleration in the x direction equals, and then same thing for the y. Then we put t in the middle because t is in the x and y direction, so really it could go on both lists. All right, So our distance in the x direction, that's our 65 meters. That's how far the ball travels horizontally. We have 65 meters. Our starting velocity in the x direction is what we just calculated, the 27.2 meters per second. And then the acceleration in the x direction is 0 meters per second squared, because there's nothing pushing or pulling it left or right. Time, we do not know. That's one thing we're going to solve for. Distance in the y, or the displacement in the y direction, we do not know that. We do not know how far the person had to jump, so we're going to leave that as a question mark. Velocity in the y direction is 12.7 meters per second per our calculation we had. And then the acceleration in the y direction is negative 9.8 meters per second squared because of gravity. So then in order to solve for time, we're going to use the list that has the least amount of question marks. So that's the x component. So to find time, we're going to use the x direction, and I want to change colors again. So the x direction, we're going to use dx equals v1 in the x direction times time plus 1/2 acceleration x direction t squared. Okay, so we're going to use our list here. We've got the displacement is 65 meters equals v1, which is 27.2 meters per second times t. And then this whole piece right here is going to be 0 because the acceleration is 0 meters per second squared. All of that goes away and equals 0. That makes our lives way easier because now all that we have to do is divide both sides by 27.2 meters per second. Actually, I'm just going to drop that out. 27.2. This goes away. I'm left with t equals 2.39 seconds. 390 if you round. Seconds. And that's our time. Now we want to do the same thing but in the y direction. Because now that we know that the time is 2.39 seconds, we can come in and solve for this now because we only have one question mark if we use this list right here. So let's use the y direction now. Y direction. And we end up with dy equals v1 y times t plus 1/2 acceleration in the y direction times t squared. So if we start substituting in, we don't have anything that's 0, so nothing's going to cross out. So we're going to have the whole equation here. So we end up with dy equals 12.7 meters per second times the time we just calculated, which is 2.39 seconds. That gives us enough space here. Plus 0.5 is the same as 1/2 times the acceleration in the y direction is negative 9.8 meters per second squared. And then times the time, which is 2.39 seconds. But we have to square that because of this right there. All right. Then if we do some simplification, this whole piece right here becomes 30.353. This whole piece here becomes negative, parentheses there, 27.989. And then we add those together, and the displacement in the y direction is 2.36 meters, which is a little bit higher than my door. So hopefully have some hops in order to get that ball. The end.